Okay, pre-calc 8.4. We are talking about vectors in three-dimensional space. Okay, so not it's just kind of an extension from 8.2. There's not much of a major difference here. You're going to kind of be doing the same things, but just extending it a little bit. So now, a couple things we've got to talk about though is the three-dimensional space. So the three-dimensional coordinate system here represents points in space. Okay, so we're going to kind of add an axis to it. So we start with your XY. You're very familiar with that, but you've got to kind of position it so it gives the appearance of depth. And so you can look at like our figures down here, 841 right here, just by putting the x-axis on a little bit of an angle, and then you flatten out the y-axis. Notice the difference here, right? X is kind of on a diagonal here, and y now is horizontal because it just kind of gives the appearance of depth. Really, you just kind of think about taking the top of the x-axis, that the x-axis was here normally, and then just kind of bending it down this way to kind of bending it back to give it some depth. And what would that do to, or that's the, sorry, the x-axis is normally here, just kind of twisting it that way. And then the y-axis, as you bend it down, would go here. Okay, so just kind of switching them, rotating them a little bit to give them the appearance of depth, so that you can add the z-axis. Okay, so here comes your z-axis now. That's going to be like the y in here in 842 that passes through the origin here. So now you can kind of see a little bit of depth. Okay, so you've got still perpendicular, still right angles. Just have to kind of use that idea that it's a corner of something. So, and notice again, here's your positive value for x, here's your positive value for y, and here's your positive value for z. Goes up and down that way. All right. So one thing it does is it goes into 8 different sections or regions that we call octants. That's the next one. And so when you first kind of look at that, what you're trying to find, if we look at 843 here, is a lot of times we look at like the corner of a room is a good description of how this looks. Right, so your floor here is the XY coordinate plane, and then you've got your walls would be XZ and YZ, kind of making that space. So I think if it's a wall, you could kind of see that kind of makes that corner and what it would look like. So this example here is a good visual for the 3 coordinate system. All right, so to plot points here, we're going to start with our ordered triple. Right, so we're going to have x, y, and z. We're going to have 3 points, and then we're going to locate x, y in the xy plane. That's the first thing we're going to try to do. And then, when we do that, kind of move y parallel to the x. That kind of helps you. And then finally, we're going to move vertically parallel to the z-axis up and down in the direction given by the z. Okay, so let's practice that and show you how it looks. Okay, so those are the instructions, but let's practice it. Okay, so remember, when we're doing this, we've got our ordered triple here, x, y, and z. So we start with our x-axis. Remember, is this one, and here's the positive for x. So I'm actually on this one, I'm going to go backwards 3. 1, 2, 3. That is where my x-coordinate is 3. And then minus 4 for y. Okay, well, remember that minus 4, this is the positive for y, if you recall. Okay, and so the negative is back over here. So we're going back 4. 1, 2, 3, 4. So I have to kind of connect those. And to do that, it kind of helps to go like draw a line across on x where you went through x. And then y, you kind of want to go parallel to your x-axis. So starting at -4, if I go up here, okay, parallel to the x-axis. So this point right there is at -3, -4. Okay, then I'm going to go up 2 because my z tells me to go up 2 from here. So basically up here is that point. Okay, so that point here is -3, -4, 2. Okay, let's try it again on letter B. Okay, so we're going to start with 3 on x. So remember, x positive is this way. So 1, 2, 3. And then we've got a 2 for y, which is positive going this way. So that's positive for y, right? So I'm going to go 1, 2. And again, where they meet. So I'm going to draw a horizontal line parallel to the y-axis. And then I'm going to draw a diagonal line that's parallel to the x-axis from 2 to kind of show where they meet. And they kind of meet right here, almost close to that z-axis. And then, or almost right on it, right? So if we say it's right on it, and then z tells us to go down 3 from there. So 1, 2, 3. This would be the point there. 3, 2, -3. It might not exactly line up with the dashes, and that's okay, because we've got 3 kind of dimensions here. Okay, one more. So 5 on x. Okay, 5 on x. And if you remember, x is positive here, y is positive here, z is positive here. It kind of helps us know. So when I do this one, my x is 5. So 1, 2, 3, 4, 5 here. And so I'm going to kind of go horizontally, parallel to the y-axis through that point. And then my y value is -4. So I'm going to go back here, 1, 2, 3, 4. And I'm going to go on a line, just kind of make a dashed line. The easiest way to find it is to go parallel to your x-axis, and where they meet is right here. And then my y says to go down 1 from there. So this point here, as I go down 1, would be 5, -4, -1. Right. All right. So that's kind of graphing them, plotting points on the 3-dimensional system. Now let's talk about distance and midpoint formulas. Okay. Nothing new here. We're just adding our z coordinates. So when we think about this one, we're finding distance between the 2 points. If we have an A that's got, a ordered triple x, y, and z, and you have B that has another x, y, and z, then we can basically stay with the distance formula, which we know is this. We're just kind of adding the z coordinates as well. So it's just an extension of the distance formula, extension of the magnitude basically as well, right? Because that's what we're trying to do. And then midpoint, same thing. We know if we add x's and divide by 2 and add y's divided by 2, that was a midpoint on an xy plane. Now we have the midpoint would just, an extension of that would add the z's to it. So add your z's and divide by 2. So pretty simple stuff. Okay, so let's practice that. Let's find the length and the midpoint of these segments. So we've got these here are x1, y1, z1. These are our x2, y2, z2. So we can use those to find those. So our length. So I'm looking at length. I'm going to go L equals, I'm going to have a big square root. And now I'm going x2 minus x1. So -9 minus a -6. And just like we did in A2, just be careful with your variables. -2 minus 6 for my y's squared plus my z's, subtracting them, -2 minus 3 squared. And now I can keep going and do the math here. So again, be careful with your positives and negatives. I get -3 squared. And here I'm going to get -8 squared for my y's, and my z's are going to be -5 squared, which then we know is going to be 9 plus 64 plus 25, which then equals the square root of 98, which then is about 9.9. And, rationalize it if we need to and stuff like that. So that's the length. So now let's do the midpoint. Okay, midpoint, we're just going to take these coordinates, add them up, and divide by 2. So you can go x1, it doesn't matter, addition is commutative here, so you can go x1 plus y, x2, or you can go x2 plus x1, doesn't matter. So let's just go for midpoint. M equals -6 plus -9 over 2, comma, I'm going to put in parentheses, my y's 6 plus -2 over 2, and my z's 3 plus negative 2 over 2. All right. So, and I can keep them as fractions if I need to. So I'm going to have a negative 15 over 2. That's fine. And then here I'm going to have 4 over 2, which I know reduces. And then we have 1 over 2, so 1/2. I could keep them and change this one, obviously, but this is fine for an answer. Right here, well, you would change this to 2, but you could change all of them if you want to, 7.5, 2, and 1/2. I almost like keeping them as fractions better, or 0.5. All right, last thing today is to talk about vector operations in space. Okay, same thing as in 8.2, nothing much changes. We're just kind of extending it and adding the third coordinate to it. Okay, so when we think about this vector addition, you've got your A plus B, you're adding them. Then I can say add the first coordinates, add the second coordinates, add the third coordinates, and you're good. Okay, subtraction is the same. I'm just going to subtract the first coordinates, subtract the second coordinates, subtract the third coordinates. Simple as that. And in scalar multiplication, also, you've got the scalar multiple k. You're just multiplying it by all three, by the first, second, and third, to do that. So very similar to what we did on 8.2. We're just going to do it here with a third coordinate, basically. All right, so 4w plus 8z. That just means that we're going to take 4 and we're going to multiply it by this vector, -1, 4, -4, because that was w. And then we're going to subtract 8 times the z vector, -2, 0, 5. All right, so the first one we multiplied scalar multiplication, so -4 times all of these is going to give us -4, or sorry, 4 times all these, -4, 16, -16. And then over here, I keep the minus sign. You could do -8 times -2 and make it a plus. I just keep the minus sign and then just go +8 times -2. Either way, as long as you just know what you're doing, you'll be fine there. This is going to be 0, and this is going to be 40. Again, I could have, if I wanted to, go -8 times -2 and make that a +16 and add that. And then the same thing would happen over here. This would be a -40, and I'd have a positive here. I could do that if you're comfortable. You're going to get the same answer either way. I just kind of like keeping the subtraction sign in there because it helps me with my operations afterwards. Just the way I prefer to do it. So now I'm going -4 minus a -16. So that's going to be 12. 16 minus 0, we know is 16. And -16 minus 40 is going to be -56. Okay. Now, so let's continue with this one then. If I do 3 times y is going to be 3 times our y vector, 3, -6, 2, plus 3 times z is 3 times -2, 0, 5. And then -6 times our w vector here, -1 or -4. Okay. All right. So let's multiply them first. Scalar multiplication tells us that this is going to be 9 minus 18 and 6 plus this one's going to be -6, 0, and 15. And again, I keep the minus sign here. And this way I get a 6 times a -1 gives me a -6 in there. And then I'm going to get 6 times 4 is 24. And 6 times -4 is -24. Like I said, you could have changed these signs. It doesn't matter as long as you get it right. So now I'm adding and subtracting across the bottom. Like I said, you could have made this a +6, but you also have to change that, right? Because negative times that would make the positive. So you could have done that and changed those signs. Either way, you're going to get the same answer. If you don't believe me, check it. So it should be fine. All right, so adding across the 3 coordinates. So 9 plus a negative 6 is going to be 3. And then now I've got a choom opportunity here. So plus 6 is 9. And then I've got negative 18 plus 0, and then minus 24. So negative 18 minus 24 is going to be negative 42. And then I've got 6 plus 15 is 25. Or sorry, 6 plus 15 is 21 minus a negative 24. This is 21 plus 24, so that's going to give me 45. And that's all there is to it today. So pretty easy section, and that's it. We'll see you next time.